Dear learners, welcome to the last part of Space and Shape. In this section, I'll be dealing with volume and surface area, hexagonal prisms, and cylinders. I'm going to try to make this video under 15 minutes, so I will be rushing through certain parts. The regular hexagon. First and foremost, I need to understand that a regular hexagon or a hexagonal prism has a base which is in the shape of a of a hexagon, and the top is the same shape, a hexagon. This hexagonal prism has 6 sides. Let's count them. That's 1, 2, 3, the one in the back 4, 5, and this one is 6. In the case of this example, I'm given a side length of 2.5 centimeters and a height of 5 centimeters. I do recall in the last video, we had dealt with calculation of area of the hexagon. There were 2 formulae. One, if the smallest width is known, and the second one is if a side length is given. In this case, a side length is given, so the area of the base is 3 root 3 over 2 multiplied by L squared. The area of the base, if I have to calculate the area of this base, now becomes 16,238 centimeters. Let's go back to what I actually want to do here. I know the area of the base. I could be asked 2 things. Number 1, to calculate the area of the hexagonal prism. The formula is the height multiplied by the perimeter of the base plus 2 times the area of the base. This has slightly been cut off, but it is the area of the base. If I were to calculate the area of this hexagonal prism, I simply use the height multiplied by the perimeter of the base. The height I know is 5 going up here. What about the perimeter of the base, this 15? I did not show this, but you need to understand where this 15 comes from. This is the perimeter of the base, which means if this is 2,5, each side is 2,5. And if I take 2,5 and I multiply it by 6 sides, I end up with 15. Plus 2 times the area of the base. This area of the base, I've already calculated it down here. Sometimes it might be wise for you, whenever you are given a question on a hexagonal prism, to first calculate the area of the base, because you are most certainly going to use it in your calculations. I end up with an answer of the area, which is 107,476 centimeters squared. Quite simple. One more time, I use this formula, and this formula will be given to you in the formula sheet. It's very similar to a formula you have done in the past. What about the calculation of the volume? If I need to know the volume of the hexagonal prism, volume is always the area of the base multiplied by the height. The area of the base means the area of this hexagonal base, which I already know is 16,238. The height is a height of 5. So the volume calculation is actually a very simple calculation, and I end up with 81,19. And remember, I am calculating volume, so this is centimeter cubed. One more time. When I'm given a hexagonal prism, I could be asked to calculate the area of the hexagonal prism, basically the surface area, or I could be asked to calculate the volume. Please take careful note that sometimes you might be given an hexagonal prism with no top, which means the top is empty. If asked to calculate the surface area, everything remains the same, except this portion here is not 2 times the area of the base. It will just be plus the area of the base, because one is opened and the other is closed. Let's go to the next portion, which is a cylinder. A cylinder is a prism. because the base is circular, the top is circular, but we call it a cylinder. Now, to calculate the surface area of a cylinder, I need to deconstruct this cylinder. Think of this as being a tin can that has a top, that has a bottom. If you want to take it apart, you will take out the top circular, you will take out the bottom circular, and you are left with this portion here. If you cut open the portion and spread it out, you have a rectangle. Look at this rectangle. Think of this rectangle as being folded into a cylinder with no top and no bottom. Further to taking out that rectangle, I need to know what is the area of this rectangle. And the area is the length multiplied by the width. In this case, it's 2 pi r multiplied by h. Also, deconstructing the cylinder left me with the circular top and the circular bottom. And the area of the circle is pi r squared. The area of this circle is pi r squared, which ultimately means that this cylinder, or the surface area of this cylinder, is the area of the rectangle plus the area of this circle plus the area of that circle. Put in formula, area is 2 pi RH, which is coming from here, plus pi r squared plus pi r squared, which is equal to 2 pi RH. Pi r squared plus pi r squared is 2 pi r squared. All I do from here is I remove common factor, which is 2 pi r, 2 pi r. And once I remove 2 pi r, I'm left with the h plus the r. Now, if you are asked to do this in the examination, you do not necessarily have to know this and write this formula. You can use this formula, plug in all known values, and you'll end up with the same answer. Be careful, because sometimes the cylinder might not have a top. If the cylinder does not have a top, then you remove one of these pi r squares, which means one of the circles is removed. If you are given a cylinder with no top and no bottom, then it's simply this rectangle where the area is 2 pi r h. The volume of the cylinder is always the area of the base multiplied by the height of the cylinder. And in this case, the area of the base is pi r squared multiplied by h. As you can see, the volume calculations are always much more easier. Let's look at a simple example. The example reads, calculate the surface area as well as the volume of the following cylinder. The radius is given as 20 millimeters and the height is 50 millimeters. The radius is 20 millimeters and the height is 50 millimeters. Whenever working with circles, please understand, if you are given the diameter, take the diameter and divide it by 2. In this example, they do not tell us whether it's opened or closed, so I'm assuming it has a top and it has a bottom. The area of the cylinder is 2 pi r into h plus r. Simple substitution, because I know the radius is 20, I know the height is 50, and I know the radius is 20. Simple substitution gives me an answer of 8,796,459 millimeters squared. What about the volume? The volume is pi r squared h. I know the value for r, I know the value for h. Simple substitution, simple calculator work, and I end up with the volume, which is given in millimeters cubed. The following examples are exam type questions. I am not going to go through the solutions in detail. I will just give you a rundown of how to solve these types of questions. Remember, prior to this, you watch the video on areas of laminas and area and volume of rectangular prisms and cylinders. Students, very quickly through these examples. Bob the builder is required to paint a fence. Bob visits his local hardware store where he buys a full can of paint. The can is 0.3 meters high with a radius of 0,1 meters. It's 0,3 meters high and 0,1 meters as the radius. The paint can is shown below. Now, whenever they ask these questions, you need to understand what units you are using. Determine the volume of the paint contained in the paint can if it is filled to the brim. To calculate the volume of paint means I have to calculate the volume of this cylinder. Volume is pi r squared h. I know the value for r is 0,1. I know the value for the height is 0,3. I end up with a volume which is 0,009424 meters cubed. A simple calculation. Bob estimates that the amount of paint required to paint the fence is 15 liters. How many cans of paint will Bob need to buy? Hint, 1000 liters is equal to 1 meter cubed, which means you first have to find out how many liters you are dealing with. 1000 liters is 1 meter cubed. You have 0,009424 meters cubed. You want to know how many liters is this. Cross multiplication, and it gives you 9,424 liters. And remember, one can contains 9,424 liters. Bob needs a 15 liter. Bob requires 2 cans of paint. So Bob requires 15 liters of paint. One can is 9,424. He can't buy one can and part of the second can. Therefore, he has to buy 2 cans of paint. I'm going to rush through the second example. Sifiso, a fitting and turning learner, completed a model for his ISAT assessment. He used a rectangular block into which he drilled a 15 millimeter diameter hole. To complete this task, he machined on top of the block a solid cylinder which has a radius of 15 millimeters and a height of 45 millimeters. This is what the model looks like. There's a rectangular block at the bottom. This is a hole that is drilled through, so it means there's space. Also on the top, he has a cylinder which has a radius of 15 millimeters, not diameter, radius, and a height of 45 millimeters. Question number 1. Determine the volume of the block with the hole drilled in it. Meaning he wants the volume of this block with the hole drilled in it. Which ultimately means I need to calculate the volume of the block, which is length times width times height. I got the volume of the full block. Then I need to calculate the volume of this hole. Remember, this is a hole drill through. The volume of the hole, because it's circular, it's pi r squared h. I know r is 7,5. The height is 45. How do I know the height is 45? Because the hole goes through this entire part of the block here. And I end up with the volume of the hole. Therefore, the volume of the block with the hole is that minus that. And I got the volume of the block with the hole. Question number 2. Determine the volume of the cylinder, meaning determine the volume of the cylinder on the top. This is a cylinder. I need to know the radius and the height. Volume of the cylinder is pi r squared h. I know the radius, I know the height. I end up with the volume of the cylinder. And it says, last question, determine the volume of the entire model, meaning determine the volume of this model. Obviously, it means I need to know the volume of this bottom part, which is this. I need to know the volume of the cylinder, which is that. And if I take the two volumes and I add them up together, I end up with the volume of this model. Now, I rushed through it just to show you how to go about doing these types of examples. In the exams, you could be given any shape. You could be given a hexagon or hexagonal prism with a hole in it, a circular hole. You need to calculate the volume of that. Sometimes you might be given a metal shape, a cube, which could be melted down and casted in the form of something else. You need to be able to do those types of examples as well. Thank you. You can now look into exam type questions.